So let's start with a statistics joke. There once was a man who drowned crossing a stream with an average depth of 6 inches. All right, statistics jokes, really not very funny. But the point here is that how could someone drown in an average depth of 6 inches? Well, it's an average. An average is not the raw data, which we talked about in our previous video. It is a summary of that raw data. And so an average comes from adding up all the numbers and dividing by the number of observational units. So it's quite possible that there is one really deep location where the individual drowned and the rest is super shallow, which leads to an average depth of only 6 inches. So the average depth really doesn't tell us why the man drowned. So we need to be able to understand the difference between raw data and between our summary statistics, our population parameters, as we are analyzing our data. So in this video, we're going to talk about the difference between descriptive statistics and inferential statistics. Now, we've looked at this visual before. This visual says we have this population of interest. So we want to know about all wheat crops. Okay, that's our population of interest, all wheat that is grown, let's say in Alberta. Okay, we have a sample. We've collected information about wheat at certain farms throughout, we hope, throughout Alberta. So we have a representation of all the different environments. And so we have a representative sample. If we just pick, say, one location, let's say we're just doing it in central Alberta, then the question becomes, is that representative of all of the wheat farms and the environments in the rest of Alberta? So we've talked in previous videos about sampling methods and whether you have a representative sample, a probability sample, or a non-representative, non-probability sample. So we try to get it to match the population. We summarize it with our sample statistics, like the average, like the standard deviation. We can graph it with the histogram, shows how much variability, the extremes, the min, the max, how much different, let's say, its yield of wheat for these different farms. We want to be able to extrapolate that to the greater population to make these statements about all wheat fields throughout all of Alberta. Now, a descriptive statistic describes what is happening in our sample. So when we talk about our sample statistics, our average, our standard deviation, those are descriptive statistics. We are describing the sample, what is happening. Inferential statistics is where we take that information about the sample and then try to make statements about that greater population that isn't known. So inferential statistics is where we try to draw inference or conclusions about that greater population. So let's define the two. Descriptive statistics is the method of organizing, summarizing, and presenting data in an informative way. So we're describing what's happening in and summarizing that information. Whereas inferential statistics is our method of estimating a property of that population. So we're using information from the sample to tell us about the population. So we're going to start in the next couple videos by looking at some descriptive statistics. We are going to look at measures of central tendency, mean, median, mode. We're going to look at measures of variability, standard deviation, variance. And then we can also create graphical representations of this information. That's going to be in our descriptive statistics. Then we can do hypothesis testing, and that would be our inferential statistics.